So in this clip, I thought I would make a video about a particular problem that I remember from when I was in elementary school that our teacher introduced to us, and I was thinking about it the other day, so I was like, why not make a video about it, because it illustrates a lot of concepts about circles. So the teacher posed a very interesting problem to us, and the question was, is it possible to cut a pie in 8 pieces, not necessarily equal, with only 3 cuts? So this is the problem at hand, and so the teacher gave us a piece of paper with a bunch of just simple 2-dimensional circles, and she challenged us to try and figure out if there was a way to do this. So little did I know was that I was being set up for failure at the time. So picture we have a 2-dimensional pie, or just this is a circle. Okay, so we have let's say that every single cut that we make is going to be some kind of a chord that we're making in the circle. And if you don't know what a chord is basically a secant line, but it's a segment, and a secant line is basically a shifted tangent line. So that's not very good. Okay, so this is basically a tangent line. This is like a secant line, and something like this is a chord, and a chord is just a segment that only goes up until the circle's boundaries, and it doesn't extend further beyond that. So let's call each cut that we're going to make a chord, and let's say that we're making n cuts or n chords, and that's going to produce our regions inside the pie for us. So notice here that this is where in this case that I drew above, we have n equals 0, so no chords, but we just have one giant region of r equals 1, because there's just one big area there for us. Okay, so now let's think about if we do have a cut in there, well then that's going to be the case where we have n equals 1 chord, and that's going to produce r equals 2 different regions for us. So okay, now what if we have 2 different cuts that we're going to make? So let's say we have something like this. Well, in that case, we have n equals 2 chords or cuts, and we have 4 different regions inside of our circle, not necessarily equal. So now let's try seeing what happens when we make 3 cuts. So if we're going to make some cuts like this, for example, in order to do it most optimally, so this would be our most optimal, because in this case we have all chords do not intersect at all one point. So this this is most optimal, and notice here that this case produces for us n equals 3 chords or cuts, but we're one region short if you add them up. So that's going to be kind of a problem for us. But in case you don't know what I'm talking about with the most optimal cuts, then let's say, for example, I was going to make some more cuts again, but this time they all intersect at one point in there. Well, that's not most optimal because we're missing out on being able to create another region by shifting that chord. So we're going to miss the central region that this would add. So this one would be a sub-optimal cut, and we would have n equals 3, but now our region count would only be 6. So this runs into a problem that we have here, that we've cut this in the most optimal way possible, such that they don't all meet at the same point. So then what now? Well, then we all had a hard time trying to figure this out, so we came back the next day and the teacher gave us a hint, and okay, so the teacher was like, picture a 3-dimensional pie instead. Well, at the time I wasn't kind of acquainted with enough problem solving to be able to recognize the huge hint here, because actually this is the only way that it's possible, is if it is 3-dimensional, because we can go 1, 2, and then if we have a 3-dimensional part of the pie right there, then we can cut it on any angle plane through the pie like this, and that's going to produce all 8 of our pieces for us. And the lines or the chords can be placed anywhere, so but in case you care about wanting an equal amount of pie, then one of the ways that you can accomplish this is if you decide to have all these be right angles that you're sweeping. So you're going to have 4 equal, what we call circle sector parts. Okay, so the sector area would be, if this is like some angle that we're talking about, then the sector area equals your angle over 360 degrees times the angle, or the area of our circle, which is pi r squared. So if we were sweeping out right angles, 90 over 360 times pi r squared, then notice that this would just be 1/4 pi r squared, and if we had 4 of those regions, 4 times the 4th pi r squared, well, that's just area equals pi r squared, and then if we cut it exactly in between, then that's how we can get equal shares of the pie, if we are interested to find that out. So this is really the trick here. You can't actually figure out the solution to this problem thinking about it in a 2-dimensional way. You have to visualize it in 3D. So hopefully this was an interesting problem for you, and you learned a little bit about circles. And by the way, if we want to generalize this for even more chords, then there's a formula. I can do a separate video about how to derive that, and it's called the Lazy Caterers sequence, and it describes basically how to cut pies or pizzas or whatever you're interested in trying to cut, and to do it in the most optimal way for n amount of cuts. So yeah, so hopefully you found this to be informational, and come back for the next video where Joe shows you how.